You know how to do function composition between two functions, and this will now be extended to include three functions. In part AI, you are asked for the domain of the three given functions. The function f of x equals 1 divided by x is a rational function whose denominator is 0 when x is 0. Therefore, x is excluded from its domain. G of x equals root x is a radical function, and the values of x that make the radicand negative are all negative real numbers. These must therefore be excluded from its domain. H of x equals x squared minus 1 assumes real values for any given real number x. Therefore, the domain of H is the set of real numbers. In AII, you must first find the composite function gh. Letting h of x be the argument of g of x, you obtain the composite function g circle h of x equals g of x squared minus 1 equals root of x squared minus 1, whose domain is all real numbers greater than or equal to 1 or less than or equal to negative 1, since the radicand cannot be negative. Other equivalent ways of writing this domain are x cannot be an element of the real numbers between negative 1 and 1, or x is an element of the set of real numbers less than negative 1 union the set of real numbers greater than 1. The composite function gh now becomes the argument of f to obtain the rational function 1 divided by root x squared minus 1. The domain of this function is the same as the domain of gh, except that since its denominator cannot be 0, x cannot equal 1 or negative 1. F circle G circle H. For A, I, since f will never equal 0, 0 must be excluded from the range. The range of G must exclude all negative numbers. Since the y-coordinate of the vertex of H is negative 1, and the quadratic is concave up since its leading coefficient is positive, the range of H is all real numbers greater than or equal to negative 1. For part B, you can see that function composition results in a function. Part B, f circle G circle H is not a function because f of 1 does not exist, and 1 is in the range of G circle H.